We are staying ahead of the curve of what we can see when it comes to weight, size, performance.
We are staying ahead of the curve of what we can see when it comes to weight, size, performance. Something big is happening in the automotive world, and no one saw it coming. While everyone is focused on electric cars taking over, one company has been working in complete secrecy, preparing to unveil something that could change everything. Christian von Koenigsegg, known for pushing the limits of engineering, has made a bold claim, one that could shake the entire EV industry to its core. Yes, so it's a technology we've been working on in a sister company which is actually behind us here, Raxial, in this room. We've been working on it for 20 years. It's been a big challenge. What is this groundbreaking revelation, and why our industry insider is saying it could rewrite the future of performance cars forever? Let's find out. Engineering excellence beyond limits. In a recent announcement that has shaken the automotive world, Koenigsegg CEO made a bold claim their new engine will obliterate the entire EV industry. But to understand this, it's important to know why Koenigsegg is in a unique position to disrupt the industry like no other company. The story of Koenigsegg begins in 1994 when a young Swedish entrepreneur, Christian von Koenigsegg, set out with a dream to build the ultimate hypercar. Unlike other automotive companies that grew out of decades-old legacies, Koenigsegg was founded from scratch, fueled by nothing more than ambition, engineering ingenuity, and an unwillingness to accept limitations. At a time when major automakers were content with incremental advancements, Koenigsegg sought to leap ahead by rethinking performance from the ground up. The company's first production model, the CC8S, debuted in 2002 and immediately set the tone for what Koenigsegg was all about. It featured a carbon fiber monocoque chassis, an engineering breakthrough that drastically reduced weight while maintaining strength. This wasn't something borrowed from Formula One or an adaptation of an existing concept. It was an innovation that would become standard in high-performance vehicles. The CC8S was a proof of concept that showed the world what was possible when an automaker prioritized engineering excellence over mass production. But Koenigsegg wasn't interested in merely creating fast cars. The company wanted to completely redefine what a combustion engine could do. Over the years, it introduced increasingly powerful models, each one pushing the boundaries further than the last. Fast, the Era-IS, released in 2015, smashed records, becoming the fastest production car in the world with a staggering top speed of 28,455 miles per hour. Unlike other manufacturers who relied on hybrid or fully electric powertrains to achieve insane acceleration, Koenigsegg remained committed to internal combustion while incorporating groundbreaking technologies that made its engines more efficient and powerful than ever before. Then came the Jesco, car designed to surpass the mythical 300 miles per hour barrier, once thought to be impossible for road-legal vehicles. Named after Christian's father, the Jesco combined extreme aerodynamics with a lightweight V8 engine that delivered an unprecedented power-to-weight ratio. Around the same time, Koenigsegg introduced the Gemera, the company's first four-seater, proving that practicality and high performance could coexist. But what made the Gyro truly remarkable was its hybrid powertrain, which combined a twin-turbo three-cylinder engine with electric motors, producing an almost unbelievable level of power output. When you think about it, Koenigsegg's success is due to its refusal to blindly follow industry trends while the rest of the automotive world rushed toward full electrification. Koenigsegg remains skeptical, not because electric vehicles aren't fast or technologically impressive, but because the company believes internal combustion engines still have untapped potential. While other brands were abandoning traditional engineering in favor of battery-powered platforms, Koenigsegg was perfecting its free valve technology, a camless engine system that significantly enhances efficiency, power delivery, and emissions control. This technology alone was a game-changer, proving that internal combustion engines could still evolve in ways no one had imagined. Despite the massive push for electrification, Koenigsegg saw the cracks forming in the EV revolution. Battery technology, while improving, still had limitations: charging infrastructure, raw material shortages, and environmental concerns related to battery production were raising red flags. Consumers who had once been enthusiastic about EVs were beginning to question whether they were truly the future or just a stepping stone. Meanwhile, Koenigsegg continued perfecting combustion engines, proving that there was still another path forward. But what makes Koenigsegg such a disruptor isn't just its commitment to combustion technology, it's the fact that it consistently achieves what others deem impossible. While mainstream automakers spend years refining minor upgrades, Koenigsegg introduces radical new ideas and executes them flawlessly. The company isn't bound by shareholder pressure or government regulations pushing for forced electrification. It answers only to engineering ambition and the pursuit of absolute performance at a time when many in the automotive world were declaring the death of internal combustion. Koenigsegg was proving that it could still be pushed further. This commitment has led to what could be its most revolutionary innovation yet, but we must look at the bigger picture and understand the state of the EV industry. A battle of technologies. In recent years, electric vehicles have surged to the forefront of the automotive industry, driven by a combination of government regulations, environmental concerns, and significant investments from major automakers. Governments worldwide have implemented stringent emission standards and offered tax incentives to promote the adoption of EVs. For instance, in the United States, a federal tax credit of up to $75,000 has been available for the purchase of electric cars, making them more financially accessible to consumers. Additionally, policies such as reduced registration fees and free parking for EVs have been introduced to further encourage their adoption. Major automakers have responded to this regulatory environment by investing heavily in electrification. Companies like Tesla, Ford, General Motors, Porsche, Mercedes-Benz have allocated substantial resources to develop new electric models and expand their EV lineups. However, despite these advancements, EV technology faces several significant challenges. One primary concern is the reliance on lithium-ion batteries, which require raw materials such as lithium, cobalt, and nickel. The extraction of these materials raises environmental and ethical issues, including habitat destruction and labor rights violations. In addition, batteries degrade over time, leading to reduced range and performance. Another obstacle is the underdeveloped charging infrastructure. Many regions lack sufficient charging stations, contributing to range anxiety among potential EV buyers. While efforts are underway to expand this infrastructure, progress has been slow and fast charging stations remain scarce. This limitation hampers the convenience and practicality of EVs for long-distance travel. Performance limitations pose more challenges. The weight of battery packs can negatively impact handling and efficiency. Additionally, real-world efficiency can vary and batteries are susceptible to overheating, especially under high-performance conditions. These factors can deter enthusiasts seeking vehicles that offer both sustainability and exhilarating driving experiences. In contrast, internal combustion engine technology, better known as the IC technology, has continued to evolve, challenging the notion that it is obsolete. Modern advancements include turbocharging, direct fuel injection, and hybrid assist systems, which have significantly improved fuel efficiency and performance. These innovations demonstrate that ICE can adapt to contemporary demands for cleaner and more efficient transportation. Koenigsegg exemplifies this progressive approach to ICE innovation. The Jesco model features a 100 horsepower engine capable of running on E85 biofuel, stressing the potential of flex fuel technology to deliver high performance while utilizing renewable energy sources. This approach not only reduces carbon emissions but also maintains the visceral experience associated with high-performance driving. Another groundbreaking innovation from Koenigsegg is the development of free valve technology. This keyless engine design allows for precise control of each valve, optimizing airflow and combustion. The result is increased power output, improved fuel efficiency, and reduced emissions. By eliminating traditional camshafts, free valve technology offers greater flexibility and responsiveness, setting a new standard for ICE performance. The Gemera four-seater hypercar initially showcased the company's commitment to redefining ICE capabilities. It was announced that the Gemera will be powered by a compact three-cylinder engine known as the Tiny Friendly Giant, or TFG for short, using free valve technology. This engine was designed to produce 600 horsepower and 600 Nm of torque, which is a remarkable achievement for its size. The TFG engine was intended to drive the front wheels while also charging in the battery, showcasing a harmonious blend of ICE and electric power. However, in July 2024, Christian von Koenigsegg announced that the three-cylinder powertrain using the TFG had been shelved due to limited customer interest, and the Gemera would instead be offered with an updated version of the 5.0L twin-turbo V8 engine from the Jesco. The ongoing evolution of IC technology, as demonstrated by Koenigsegg, suggests that internal combustion engines still have a role to play in the future of transportation. While EVs offer a pathway to reduced emissions, the challenges they face indicate that a diversified approach to automotive innovation may be more practical. The EV industry struggles. The electric vehicle industry is navigating a critical inflection point characterized by a complex interplay of technological, economic, and market challenges that are fundamentally reshaping the trajectory of automotive Electrification, what was once viewed as an inevitable and rapid transition to electric mobility, is now revealing itself to be a more nuanced and gradual transformation. Global automotive manufacturers are confronting a multifaceted landscape of obstacles that are forcing a strategic recalibration of their electrification ambitions. At the forefront of these challenges are significant economic barriers that are testing the resilience of the EV market. The initial promise of electric vehicles, lower operating costs and reduced environmental impact, is being tempered by substantial upfront costs and infrastructure limitations. Despite technological advancements and economies of scale gradually reducing battery prices, the purchase price of electric vehicles remains notably higher than comparable internal combustion engine vehicles. This price differential continues to be a significant deterrent for many consumers, particularly in markets with economic uncertainty. The infrastructure supporting electric vehicles presents another critical challenge. Charging networks, while expanding, remain inconsistent and inadequate in many regions. Range anxiety persists as a genuine concern for potential buyers, with the availability and reliability of charging stations varying dramatically between urban and rural areas. This infrastructure gap is particularly pronounced in countries with less developed electrical grids or in regions with extreme weather conditions where EV performance can be significantly impacted. Major automotive manufacturers are responding to these challenges with an increasingly cautious and pragmatic approaches. Even companies that were once aggressive in their electrification timelines are now undertaking significant strategic adjustments. Ford, for instance, has canceled plans for several all-electric SUV models, while General Motors has scaled back its production targets. Mercedes-Benz reported a substantial decline in electric vehicle sales, and Volkswagen has delayed its EV expansion plans. These actions reflect a broader industry recognition that the path to electric mobility is more complex than initially anticipated. The global supply chain has emerged as another critical factor complicating EV production. Raw material costs for essential battery components, including lithium, cobalt, and nickel, have demonstrated significant volatility, creating additional economic uncertainty. Geopolitical tensions and disruptions stemming from the 2020 pandemic have further exposed the fragility of the automotive supply chain, leading to component shortages and production delays that have rippled through the industry. Government policies and incentives are also undergoing significant transformations. While many regions initially offered robust subsidies and tax incentives to promote EV adoption, some are now scaling back these programs. The European Union, for example, has extended CO2 emission target deadlines, signaling a more measured approach to automotive electrification. These policy shifts create additional uncertainty for manufacturers and consumers alike. Consumer perception and technological expectations play a crucial role in the EV market's evolution. Many potential buyers remain concerned about battery longevity, replacement costs, and performance in diverse environmental conditions. The real-world performance of electric vehicles, particularly in extreme temperatures, continues to be a point of scrutiny and skepticism for many consumers. This complex scenario has prompted serious discussions about the most practical path forward for sustainable transportation. Rather than seeing the current challenges as a defeat of electric vehicle technology, industry experts are increasingly advocating for a more balanced approach. Hybrid vehicles and continued improvements to internal combustion engine technologies are being reconsidered as viable interim solutions that can provide meaningful emissions reductions while addressing current technological and infrastructure limitations. The current state of the EV industry reflects a mature and realistic assessment of the enormous complexity involved in transforming a global transportation ecosystem. It is not a binary transition from fossil fuels to electric power, but a nuanced, multi-year journey that will require continuous innovation, infrastructure development, and adaptive strategies from manufacturers, governments, and consumers alike. Looking forward, the most successful approaches will likely be those that embrace flexibility and incremental progress. It is a time for careful strategy, continued investment in research and development, and a recognition that technological transitions are rarely smooth or straightforward. The hybrid revolution, a more practical solution. The debate between internal combustion engines and electric vehicles has paved the way for a compelling alternative: hybrid vehicles. These vehicles blend the traditional ICE with electric propulsion, offering a balanced approach to modern transportation challenges. Koenigsegg's forthcoming engine exemplifies this paradigm shift, challenging the notion that full electrification is the sole path forward. In fact, their CEO thinks that EVs will completely vanish after their new engine hits the market, but we will get to that really soon. Hybrid vehicles have re-emerged as a practical solution, combining the benefits of both ICE and electric systems. Models like the Toyota Prius, Ferrari SF90, and McLaren Artura illustrate the versatility and appeal of hybrid technology across different market segments. The Toyota Prius, for instance, has been synonymous with fuel efficiency and environmental consciousness, making it a popular choice among eco-friendly consumers. On the other end of the spectrum, high-performance hybrids like the Ferrari SF90 and McLaren Artura demonstrate that hybrid technology can enhance performance without compromising on power. One of the primary advantages of hybrids is their ability to lower emissions without sacrificing the convenience associated with traditional vehicles. By using a combination of gasoline engines and electric motors, hybrids can reduce fuel consumption and greenhouse gas emissions. This dual-system approach allows drivers to experience extended driving ranges and quick refueling times, addressing some of the limitations faced by fully electric vehicles. Additionally, hybrids often come with regenerative braking systems that capture and store energy, further enhancing their efficiency. Koenigsegg, renowned for its innovation in automotive engineering, has already introduced the Gemera, a groundbreaking four-seater hypercar that showcases the potential of hybrid technology. The TFG engine's innovative design eliminates the need for camshafts, allowing for precise control of the intake and exhaust valves. This results in improved efficiency, reduced emissions, and enhanced performance. By integrating this advanced ICE with electric motors, the Gemera achieved a combined output of 1,700 horsepower and 3,200 Nm of torque. This configuration enables the Gemera to deliver exceptional performance while maintaining fuel efficiency, exemplifying Koenigsegg's commitment to keeping ICE relevant through continuous innovation. Beyond traditional gasoline, alternative fuels such as synthetic fuels, hydrogen, and biofuels present viable options for reducing the environmental impact of ICE vehicles. Synthetic fuels, produced through chemical processes using renewable energy sources, can significantly lower carbon emissions. Hydrogen, when used in fuel cells or as a combustion fuel, emits only water vapor, offering a clean energy solution. Biofuels, derived from organic materials, provide a renewable energy source that can be integrated into existing fuel infrastructures. These alternatives offer pathways to sustainability without requiring a complete shift to full electrification. But have you ever thought about how Koenigsegg's CEO looks at the EV transition? Christian von Koenigsegg's stance on EVs. Well, Christian von Koenigsegg, the founder and CEO of Koenigsegg Automotive AB, offers a distinctive perspective on the push toward full electrification. Now, Christian's stance is rather provocative. In conversations with automotive media, including a notable interview with Top Gear, he has consistently emphasized that electric vehicles are not the sole solution to sustainable transportation. His approach rejects the one-size-fits-all mentality dominating the automotive sector, instead proposing a more comprehensive strategy that integrates alternative fuels, hybrid technologies, and ultra-efficient internal combustion engines. The core of his critique lies in the limitations of current electric vehicle technologies. He points out the discrepancy between manufacturer-claimed range figures and real-world performance, noting that factors like driving conditions and battery degradation significantly impact actual vehicle capabilities. This perspective challenges the often unrealistic marketing narrative surrounding electric vehicles, calling for a more honest and pragmatic approach to automotive innovation. Perhaps most compelling is Christian's emphasis on technological diversity. While many manufacturers rush headlong into full electrification, he argues for a more nuanced approach that explores multiple avenues of sustainable transportation. Synthetic fuels, hybrid systems, and advanced internal combustion technologies represent viable alternatives that should not be overlooked in the pursuit of environmental sustainability. The company's business model further underscores this philosophy. Operating in the ultra-exclusive hypercar market, Koenigsegg has the unique ability to experiment with cutting-edge technologies that larger manufacturers might find too risky. This approach allows for unprecedented innovation, particularly in developing ultra-efficient internal combustion engines and exploring alternative fuel technologies. Concerns about the wider implications of electric vehicle production also drive Christian's perspective. He has voiced significant reservations about the emerging monopoly in battery production, emphasizing potential issues with resource availability and supply chain constraints. This critical view extends beyond mere technological considerations, addressing the broader economic and environmental implications of a wholesale shift to electric vehicles. The regulatory landscape provides another interesting dimension to his approach. By operating at a small scale and targeting a niche market, the company enjoys remarkable flexibility in navigating automotive regulations. This allows for more innovative design approaches that might be impossible for larger manufacturers constrained by mass production requirements and stringent regulatory frameworks. Ultimately, Christian's philosophy represents a sophisticated challenge to the current automotive paradigm. Rather than fully embracing electrification or entirely rejecting it, he advocates for a balanced approach that prioritizes technological innovation, performance, and genuine environmental sustainability. His perspective suggests that the future of automotive technology is not about wholesale replacement, but about the intelligent integration of multiple technological solutions. Looking beyond the EV versus ICE debate, the traditional debate between EVs and ICEs often overlooks the potential of synthetic fuels to revitalize high-performance combustion engines. Synthetic fuels, also known as e-fuels, are engineered to be carbon-neutral alternatives to fossil fuel. Notably, synthetic fuels can be used in existing internal combustion engines without modifications, offering a seamless transition towards sustainable mobility. Hydrogen combustion engines present another intriguing alternative. Unlike hydrogen fuel cells that generate electricity to power motors, hydrogen combustion engines burn hydrogen directly, producing water vapor as the primary emission. This technology leverages existing ICE architectures while offering a zero-carbon solution. However, challenges such as hydrogen storage, distribution infrastructure, and combustion characteristics need to be addressed to make this a viable mainstream option. The global push toward electrification has led many governments to propose bans on new ICE vehicle sales in the coming decades. However, as alternative technologies like synthetic fuels and hydrogen combustion gain traction, there's potential for policymakers to reconsider these bans. The adaptability of existing ICE vehicles to run on carbon-neutral fuels could provide a pragmatic pathway to reducing emissions without requiring a complete overhaul of current automotive infrastructure. Now, Koenigsegg has a storied history of defying conventions and setting new benchmarks in automotive engineering. The Jesko Absolute, for instance, has set multiple world speed records, including the fastest 0-250 mph time, showcasing the brand's relentless pursuit of performance excellence. As I have already mentioned, the cornerstone of Koenigsegg's innovation is the development and implementation of free valve technology. This calmness engine design allows for independent control of each valve, optimizing performance, fuel efficiency, and emissions. The technology has been successfully integrated into production models, proving its real-world applicability and effectiveness. Looking ahead, Koenigsegg's commitment to pioneering advanced technologies positions the company to potentially revolutionize the automotive industry once again. Their forthcoming engine, shrouded in anticipation, is expected to challenge the prevailing narrative of full electrification by offering a high-performance, sustainable alternative that leverages the best aspects of ICE innovation and alternative fuels. But what is their secret? Back to the future. Well, according to insiders from the company just a week ago, Christian Koenigsegg gathered a group of his most trusted people. Standing on the stage in their presentation room, the Koenigsegg CEO said, "Our new engine will obliterate the entire EV industry. We are making this by the end of this year. My decision is made. So pay close attention." The room was silent for a moment. Christian had never been one to make empty promises. Every time he and his company set out to do something, they not only achieved it but often surpassed even their own expectations. This time, however, was different. Christian was talking about challenging the entire foundation of the auto industry's current path, one that had been dominated by electrification, regulatory pressure, and the gradual phasing out of internal combustion engines. Insiders say that what Koenigsegg will be working on in the next couple of months is unlike anything the world has seen before. While major automakers are racing to develop the next best battery-powered supercar, Koenigsegg's approach remains rooted in something far more complex, yet potentially revolutionary. This new engine, according to those in the know, is poised to combine everything the company has learned over decades of research, from free valve technology to hybrid integration, alternative fuels, and beyond. One of the key takeaways from Koenigsegg's statement is the clear conviction behind it. There was no hesitation, no uncertainty, only a definitive commitment to seeing this vision through. So yes, we can expect to see the debut of this new engine by the end of the year. And insiders suggest it will incorporate an advanced free valve system with ultra-high compression ratios, allowing for unprecedented efficiency and power output. The engine is said to utilize a hybrid-assisted forced induction system, potentially integrating electric turbochargers to eliminate lag while optimizing combustion, which could mark a major breakthrough in ICE technology and directly challenge the dominance of battery electric powertrains. Just like Christian announced, the only question that remains is, will the rest of the industry be ready for what's coming next? What do you think? Let us know in the comments.